My name's Mike Barwise. I am the creative director at Marmalade Game Studios next door. And as Lester says, we get to have a lot of fun making games. That's great. It's really something we're passionate about. The topic I'm going to talk to you today about is best practices for game development. So there's two outcomes, I think, from this particular talk. One is that you get a bit of knowledge and a bit of insight into how we make the games. We know we share the roof with the SDK team, so how do we approach making games with Marmalade? Or the other outcome is maybe you realize actually you do some things better than us. Either way, I just want you guys to feel great about how you make games, and you'll learn something either of those two outcomes. So the first thing, I'd quickly talk a little bit about ourselves, because we're old yet we're new. We were Ideaworks Game Studio, working on all these kind of titles, Black Ops Zombies, Lara Croft, Game of Life, Backbreaker, and they were all built with Marmalade. We've made a couple of other titles as well that weren't built with Marmalade, but our future kind of got defined when we started working on a title towards the end of last year called Signal to the Stars, and that was built using Marmalade Quick, so that was a new technology at the time. Building a game at the same time as newly developed technology was really an interesting challenge for us. We had a lot of chance to feed into the development of that particular part of Marmalade, and we also had great fun in making a game at the same time. And it was an outcome of that process that, yeah, let's push forward, let's be more tightly associated with Marmalade, and hence we rebranded ourselves to Marmalade Game Studio. A little bit about myself. So I've been working in games for many years now, worked in design all my career on titles such as these. The reason that I've now left kind of a console history and gone into mobile is I'm really energized by what mobile gaming has been and what it's going to be going forward. And what I like about Marmalade is some of the things I had when I worked with console is that you have a PC simulator, so when you want to rapidly test and try things, you've got a really cool and quick route to be able to test your content. So when I was working on the Wii, for example, actually sometimes we'll be doing a lot of our design or testing on a PC build. We've got that now today with Marmalade, so that's why this is the type of company that I was really excited to be a part of. Then about this talk, well, it's not a lecture on game design because I'm not qualified to talk to you about game design, even though that's my craft. You guys, you're making your projects. You've got your own indie dreams you want to make real. You've got games or apps that you're making for clients. You know maybe specifications that they want. That's not for me. I can give you a little opinions, but it's not a best practices on game design because that just wouldn't be possible. However, what I definitely can tell you about is how we do our process. How do we make games with Marmalade? The types of things we focus on when we're actually building, and then the processes that power that. So these are the type of topics I'm just going to be rattling through today, splitting into the two areas, actually the process, which is more the people, how we organize, how we hand over things between each other, and then the development, the first section I'm going to cover, which is how we really use tools and little techniques along the way to rapidly iterate and always hopefully end up at a great product. So firstly, one of the things we have is an on-device debug menu. Now you have the PC simulator, as I've already mentioned, and I think that's brilliant. Like I really love having that, but it's got its limits. You've got a mouse or a keyboard as your input source. So when you want to do multi-touch gestures, for example, it's not really possible, at least to my knowledge at the moment. You also want to be able to test things like performance and get metrics and feedback from that. So what we have is on our app, you can slide along the top of the screen. It's a gesture that isn't used in any of our current games, so it's hidden yet very easily accessible. And then you're into page after page of what is useful tweaks. Often a lot of what they're doing is just changing variables. This is brilliant for a designer who wants to be able to balance a game, so make the health of the enemies lower, higher. They can do that on device. The speed that a crosshair maybe moves at in a first-person shooter, again, they could try that on the simulator, but the real rubber hits the road test is when we do that on a device. So this is easily summonable. It allows us to do lots of things that are kind of real for the player. There's no emulation step involved. And on any of the cases where the game may go wrong, you can have a chance to get further information out of your QA department. you've got this menu, you can bring it up, maybe retrieve some nice handy things about what state the game was at the time the error was seen. That's if you build any errors into your software, of course. We try not to. A common problem, and that you'll inevitably face when you're making anything that's interactive on the mobile platform, is how you're going to tackle the problem of different screen aspect ratios. There definitely isn't a one-size-fits-all approach, but I'm going to talk to you today about a couple of real examples on games that we've made or are in the process of making that show how we tackle this. So with Signal to the Stars I mentioned earlier, we knew we had on-development tech, so we wanted to build something quite constrained that could scale as appropriate as the tech was being developed. We weren't going to set out to make a 2-year project. No, it's about we wanted to make something that would help shape the tech, have a nice release at the end of the day. So a quick iterative game cycle there. So for this game, we chose a grid size that would be the same across all our platforms. So you can see, no matter if I'm on a 3:2 aspect ratio iPhone 3GS or iPhone 4, all the way up to the iPad, I'm not losing any of the critical gameplay space. So that was like a smart design choice, I feel, that in this game we have lots of nice opportunity to see the extra art, but it's something that is only extra. It's not going to affect your experience, whatever platform that you intend to consume the game on. So that was the way we tackled it on that particular title. But moving forward, I can't show you a real screenshot of what we're working at the minute, so I have a mock-up. This is how we tackle it in maybe a 3D space. We can try and constrain our camera, and we choose either the horizontal or the vertical aspect to then lock. And that will be the one that we ensure is the same across all our platforms, whatever they are. So here, for example, the iPad is shown in the white, the 4:3 type of screen aspect space. And we've got our 4 zombie attack points. And we know no matter what, because we have this extra space in the darker gray on an iPhone 5, there won't be extra gameplay in those spaces. The zombies only attack in a space that's guaranteed to be on every platform. So we don't have edge cases, we don't have specific design we have to do to cope for those other platforms. Also, it's the same experience as much as we can get on the platform wherever we can. If we wanted to take it differently, if we're making, say, a Mario game, a horizontal scroller, that's where knowing what's coming up on the right-hand side of the screen is actually a pretty important part of the platform game genre. So there we would probably choose to constrain on vertical. So on horizontal. We fix horizontally, so every platform would have the same amount of look ahead for where enemies and gaps, etc., are coming up. But then you see extra ground and sky on the vertical axis. This way, the gameplay, the really core part, can you read the world, can you see the enemies, that's kept intact. And the more optional, aesthetical part of seeing more sky or ground, that's something that we're happy to cede to other devices of different sizes. Low-end device support is important because Marmalade gets you to lots and lots of platforms at once, and that's fantastic, but they've all got different specifications. Not everyone's going to be on the very latest version, for example. So we've come up with a few tricks that we employ to try and keep low-end devices working as best as we can get. That keeps us happy personally. It also keeps our clients happy. So if you have hardware rendering available, fairly simple, just use it wherever you can. So hardware skinning on your characters. If you need to keep the bone limits down to achieve that, it's worth the performance gain you get. It's going to vary from game to game. If you have a very detailed character, for example, you may not be able to achieve that, but it feels knowing that in advance of what you want to turn on hardware side is can be a real benefit later on. You won't have to make compromises to your experience to achieve a decent frame rate. That leads then on to exactly frame rate. We have here a grab of our current output. This is on all the time, so we know our current frame rate and then our smoothed frame rate, our rough average over the last second. So everyone is aware when they pick up a build of the game on device what's a frame rate at? So that's really nice information to have, because when after, say, a particular check-in, maybe some particle effects, or the artists get a bit carried away and build a nice, really detailed world, you can identify where your frame rate has gone wrong, and knowing where it's gone wrong is one of the quickest routes to then be able to fight back against it. So you've got a point in history you can trace backwards to, and then address the problem. Inside, actually, the different devices, we have a profiler we can use to work out how long certain parts of the game, for example, rendering or any other networking calls, take. On PC and iOS, we find this is very reliable. The timers report correctly, but on Android, there isn't a consistent way of getting that kind of information out. That's what we found. I can talk a little bit more later if needs be on that. But having the simulator honoring and correctly reporting the profiler, that's a great starting point. Simple. Don't forget about memory. We have here what we aim for as total memory loaded in at one point. This is to power the low-end device, so a 3GS is the minimum spec that our game will support. We can handle 30 megabytes of game data loaded in at once, so always being aware of that, knowing how close we are to that limit, and then potentially pulling back from it if needs be, that's really handy information. And as I say, it's always there, so that anyone on the team can be noticing this type of readout. Something to think about, if users can download your app, say it supports iOS 5.1, an iPad, even if you put in your text, warning, app does not support these platforms, you will still get people download it. They won't read that, they'll just see the download button, go for it. Then what you know, a few hours later, you get a 1-star review from someone who can't launch your app. So you do have to take this seriously, I feel, that if your app can be possibly run on a low-spec device, either block it or cater for it. Be caught in the middle, you will expose yourself to the risk of bad reviews. Okay, so our current project is simultaneous iOS and Android development, and some of the ways that we can achieve that smoothly is we never really have a lead platform. Okay, and honestly, in the early days, we did start on, for example, iOS, and then branched out to Android. But once we got to that point, then we don't leave either one behind at the expense of the other. So every build we do to review is done on both platforms. We have a great spread of different devices around the team. I own an iPhone, for example. I know people on Android devices. We'll all be seeing the game at the same time, the latest head revision of the code, and we can compare our experiences. It's not that Android is once a week and it's a thing that's forgotten about or slogged through. No, it's kept just up to date as the iOS version. However, having said that, when you do come to a piece of platform-specific functionality where you maybe do need to write an extension, yeah, you will probably pick a lead platform, get it working, check it's doing exactly as you intend, then write the equivalent extension for the other platform. And it's in your interests to keep that as unified as possible. Different code, sure, but the outcome being as similar as possible. Because you won't then have problems debugging later or any expected platform-specific problems. Something like the Android back button is actually one of the last things we add, because we feel pretty confident that we know that that's how it's going to work. And it's just one of the kind of the key parts at the moment with our current project of where we know there'll be this differentiator. But we're comfortable with that. If we had billing solutions, then we would have to be dealing with those a lot more seriously and making sure they worked simultaneously. Okay, on continuous integration, every commit from our coders forces a compile on our Jenkins server. So that means a code is constantly being built and evaluated. This is great for many reasons, that it acts as a safety net for developers who, we're human, we do make mistakes, and bad code can go in, cause a compile error. So knowing this is always working to police that is great. You've got a safe mainline. And Jenkins can also be set up to actually go on to not only compile, but create the full build. So every check-in, if you wanted to, output that to a build. So you've got a good parity between what the actual perforce or your head revision, wherever you choose to keep that, is kept at equals your device, how the game works on then. Sorry. Okay, on analytics. This is a huge subject in itself, and way outside the scope of what I can talk about today. But the things that I feel are important for how we work is it's always worth the time to implement analytics. I do remember quite vividly on Signal to the Stars having the discussion about should we put any analytics into the game, having that sort of priced up in terms of how many days of coder time it would take, and we didn't take it. And that was a mistake, total mistake, because when the app did launch and we had lots and lots of downloads, but we failed to convert them as highly as we'd like, we were blind to some of the reasons why. And it just, you could take a moment back in time, that's definitely one that I think we should have reappraised. It is worth the time. You will be finding and learning so much out about how your game is working in the wild. It's worth that time to spend in the development phase to get them in. Having said that, though, I do feel they are a tool to be used in your development rather than something that becomes a literal rule. They're not a design by spreadsheet approach of where numbers are used rigidly to prove or disprove a particular theory. I still think you need to keep developers, humans, designers, whatever, in the loop of what feels a good decision, what feels like your experience and how you feel about the game. That's important. Maintain that, then use numbers to guide some of the more specific and key learnings. It can also help guide your development phase. So actually having outputs of, say, high scores or pathways, funnels through your app, even when your app is in development and where you choose to share it with other people in your team or friends via other methods, you're getting the information early. And I think that's really important. So you don't have to wait necessarily for the customer launch. You can be doing this through development. On localization, it's not really a tricky problem in itself. It's just something that tests how good you are in your process, how well you hand things off to someone else or another part of tool or process to do. So it's not rocket science is basically what I'm trying to say. How we do it is we have a Google Doc-based database. That way anyone on the team can get into it and add their text that they need localized. Also the translators that we send this file out to, that's live. They can be looking at this, checking when new text has been added, and then translate all separately. No one's getting tripped over a single exclusive checkout file or some other process like that. Making sure all your text goes through one single rendering pipeline also allows you to, if you're not yet ready for localization, do things like have an uppercase switch so all hard-coded text comes out in capitals or with a pre or a postfix. So you're not finding surprises later in development of where that text is coming from. You're trying to track it down. You're more clear exactly where this can be coming from because it's all going through that one single pipeline. When we have to deal with actual art assets, for example, we have different logos. We're making a game for a client, and there's different territories require different logos. We have a check in our resource manager. We tell it via the editor, this is a localized asset. And then when the resource manager goes to load that for the first time, it then looks extra for a postfix, en, fr, de, and picks up the localized asset. However, that's to be avoided where you can, because you've obviously got the cost of then creating these extra art assets. When you incur change in them, you've got to then go through art to do them, which is more work than just pure text rendering. So you can avoid it, but there's some places where it is impossible to do so. The other thing, we have lots of people upstairs that are part of our team that aren't programmers, they're not developers, as you may specifically term. So we do have artists, animators, and I say designers, QA. What we do is we package up the simulator, have it scan a particular area on the hard drive for then to pick up assets. So this way the simulator can be used as a way to test the latest version of game code, but allow that particular content creator to view their work independently. They don't have to wait for a check-in and a build and get them onto device. They can be using this non-programmer's build or the art build to check how their work is going. You know, does it render correctly, normals all the right way in and out, performance, all that type of the issues that are very much part of the game iteration process. That all then can happen independently of a coder. And we keep this as up to date as the mainline. Talking about continuous integration earlier, when Jenkins does a compile of the latest check-in, the result that will also be an update to the art build. So the artists aren't getting left behind. Again, it's not a once weekly build. It's exactly the most up to date as what the game code will be running. I have written an intentional mistake up there that I've changed since or found out a little bit more information on, that actually it doesn't require a Marmalade license. You package the simulator up in this way, it's just a standard executable, and that can go to your artist. They don't have to have a copy of Marmalade installed because they're not directly compiling, they're not building with it, they're just running what's been built by it from an engineer, if that's clear. Okay, so onto our process and how we actually deal with making the games between teams and towards our overall goals. We use something called baby steps development. Hands down, this will be the worst PowerPoint image you see all day, but it will make some sense. This is where traditional game dev sometimes works. You know where you are, and you know where you want to get to, and then you'll just plow on a big, long jump to get there. And I think we feel quite strongly there's a different way to be making games, and that's a more iterative and software-driven, through prototypes, way of developing. But if you make this is a huge, big jump, and you can get here, and it's wrong. You play it, and it's wrong. It's not right. It doesn't look right. It doesn't communicate well. So what we try and do is work on a smaller baby steps model. You know, imagine each of these is a little hop. So we start small and build small steps. We know where we're going to, so we set out on the same direction. We know where we want it to be, but we didn't try and build it all at once, set every department running on it. We started with the core parts of the software, mainly the engineering, and we took our baby steps, and then we got somewhere and you realize this isn't working quite as well as we thought, or actually, this doesn't look so good anymore over here. What if we did this and went in this direction? So by taking these small steps, always based around the software, always with something playable, rather than in theory and documentation, you are basing it on true facts. Shove the device in someone's hands, and that can pick them up and see where you're headed. That's how we work out, and we can end up somewhere very different to where we thought we were going, but we've got there in a really measured and known way. We can track back and see, this was a great place where we could add something we hadn't thought of. But if you make it in one big jump, you don't have this chance for opportunities and being alert to something better than you thought could actually originally happen. To make this work, you do have to be prepared to fail fast and then move on from that. And I'm personally quite a big believer. It's totally fine to fail when you're making games. It's just fail very quickly. Don't be in the prototyping portion of all of this that powers it. It's making sure you have the right things in the game that do the prototyping. So if you're making a platform game, for example, and the character is a horse, I would say the way a horse jumps, front legs first, back legs second, that's going to be quite integral to how that character feels. If you just prototyped with a block a rectangle and it jumped and really linearly, you're missing something that then will be part of your experience later. So you've got to work out what are the appropriate things you can get a cheap representation of in prototyping and press on with those. So in case of the horse, I think you would need to do something a bit more advanced than just a cube or just a square or just something, an image off the internet. I think that will be something that is more ingrained in the experience, and failing to prototype the parts that make that work or make that unique early, you'll just be masking the problem and thinking you're making great prototyping progress when you've actually just not done the extent that it should be. So to organize and collaborate amongst ourselves, because it's driving a team of multiple different disciplines towards a goal, we use Trello. It's an online kind of collaboration space. You add lots of cards and you can organize it pretty much any way you want. What's great about it that we like is it's public and interactive. We use it in our daily stand-ups. We have it on a screen at the start of the day, but then it's something that anyone can check on their browser, or it's got apps for all the major platforms that you can check, while you're at home as well. So it's public, everything's out there, what's someone working on, what they got coming up next. You can really clearly see that. It's also interactive. There's a tactility in dragging tasks around between people that suddenly makes it feel all the more real. When you've been dragging 5 things onto one of your programmers, that's telling you actually that guy's got a lot to do now, or you just get a better sense of scale and size and where you are in the development process. It is also visual, so you have a great feeling when your complete bar or your area is full of cards. Great, I've done loads this week, there's tons to review. It gives you the team that visual sense of, wow, these tasks really are going somewhere. It's not just the game, it's also the tracking that's helping you realize progress. And it's very flexible because there's not really a set way to use it. It's not a project planning tool. I wouldn't be making all my schedules based on it, and I wouldn't be tracking to hours and days by it either. We use it in a much more fluid way that suits our baby steps model, where we can turn up at the start of the day and be saying, you know what, I think we should be trying to add this type of weapon into our game. Someone's got that idea, they've realized the opportunity, we add it on to someone's backlog, as it were, and then it gets moved up through priority. It's not a big static thing. It does change on a daily basis, with new stuff sometimes getting added and the old stuff, as it's done, promoted off. It's also free, and you can't fall off free. Skype. So we're a studio, we're next door, we share the same office and large desk space with a lot of the members of the SDK team, which may make you think it's a bit odd that we use Skype because, well, we sit next to each other. And actually, I think that's fine. It's not unsocial to use Skype. There's some really good reasons why we have everyone set up on it. So we have channels for each game that we're working on, or there's a programmer's channel, there's an everyone channel, there's maybe a chit chat, and you can broadcast to each of these your current update or what you're working on, or just something that's relevant to the current activities of the whole studio. And how it works is that the whole team sees that discussion. If a programmer and a designer have had a water cooler chat about something, only they will know. If you've done it over Skype, lots of people can pick up the history and see, oh yeah, that's something that was being talked about earlier. I'm now going to have to maybe change my thinking or be prepared for this to happen coming up soon. It's got a stored history, 7 days, 30 days. I think it goes as far as 6 months even. When you sometimes need to prove where something went wrong, or when a ball was dropped, or why did we do this? Can't remember. You can go back through the history and realize, oh yeah, we did it because it was rubbish, or the frame rate was terrible, or we found the audience when we play tested it just didn't enjoy it. So you've got that to rely on. And even in a studio where we do sit next to each other, people are away from keyboard. We've got meetings going on, holidays, illness, or just generally talking to each other. So when you get back to your desk, you can catch up on what's been going on one of these channels, and we find that really, really handy. It can be noisy. It can disrupt your flow when you have something honking at you, bright orange, but then equally, If you're going around the programming group and maybe you're asking for a buddy check, well, you go on, you tap them on the shoulder, that's interrupting someone whether they liked it or not. At least with Skype, if you put the message out, can I have a buddy? If someone really is busy, they can choose to set their settings and they don't have to see this. So even though we're a social studio and we aren't mute, we do talk to each other, we don't set human communication back thousands of years, we find this is a good help for us. We use something called pstart, made by PegTop. It's a free piece of software, I think primarily targeting Windows, and it's a centralized collection of tools and shortcuts. It allows us to ensure the team are using the latest version of the tool because there's one route to where they launch the tools from. So you've got links to different folders where content should be going in. You've got to the MKB, you've got to various tools, Trello or Jira for bugs. One route, so people are always going through the same way. They're not finding it manually, 3 different routes, and then you've got to track down sometimes which developer's got the broken one. So it does save you productivity in that sense. It also is just a simple productivity saver in its own right, that you click, you save in clicks, call this up from your taskbar, and you can quickly be into the MKB, into the art build, check my Trello, what tasks have I got on. Sounds simple, it's, we're only talking a few clicks, but over the course of days, weeks, months, that adds up to quite a lot. And it's just a mental thing. It keeps you in the flow easier because everything's much more at reach. On TestFlight, probably no surprise, lots of you can use it here. It does support iOS and Android. It's just a great way to be sharing builds, and we use nightly builds, so every day at the end, sometime at 2 a.m. in the morning, a version of what's the current mainline is then pushed out to everyone on the TestFlight group. So that allows the team to sort of be picking the game up at home, maybe for the commute in, or first thing before the stand-ups. Everyone can be guaranteed to have access to the latest version. That means you can surround yourself in the game development, should you choose to. Obviously, we need to have breaks sometimes. We're human after all. But when it really matters, when a feature is kind of nearing the point at which it's going to be great, or it needs to go back a cycle of iteration, you want to know you're looking at the latest. And that's how we organize our TestFlight, that it's a free resource. We'll fill it up with builds as long as they're allowing us to be using it as the way we are, and we've got no problem with that.